Let me ask you a question. It sounds really simple, but it might just break your brain a little. We all kind of feel like we know what infinity is, right? It just keeps on going, forever. But what if I told you that some forevers are actually bigger than other forevers? All right, let's put that to the test. Just look at these two sets. On one hand, you've got all the whole numbers, 1, 2, 3, on and on. On the other, you've got just the even ones, 2, 4, 6, and so on. Now, your gut, your intuition is probably screaming that it has to be the whole numbers, right? I mean, come on, that set has all the even numbers plus all the odd ones. It seems like a total no-brainer. But it's not a no-brainer. Mathematically speaking, they are exactly the same size. Now, if that feels deeply, fundamentally wrong to you, you're not alone. Welcome to the absolutely bizarre and beautiful world of George Cantor, a man whose ideas about infinity were so revolutionary, they were literally called heresy. To really wrap your head around this wild idea, you first have to understand the man who came up with it. See, George Cantor wasn't just some mathematician scribbling in a dusty office. In his mind, he was on a mission from God. Cantor was a man of incredibly deep faith. He wasn't just doing math, he believed he was a channel that God himself had picked him to uncover these sacred truths about the infinite and share them with the world. For Cantor, his equations and his theology were the exact same thing. It was all one big quest for the divine. But here's the thing about a divine mission. It tends to put you on a collision course with the establishment. And back in the late 19th century, a fierce battle was raging for the very soul of what mathematics even was. And this whole conflict really boils down to two totally opposite camps. On one side, you've got guys like the very powerful Leopold Kronecker. They're the constructivists. For them, math is something humans invent. It's like building with Legos. You start with the simple numbers, 1, 2, 3, and if you can't build it from there, step by step, it just isn't real. But then you have Cantor's side, Platonism. He believed math isn't invented, it's discovered. The truths are already out there, existing in some perfect abstract realm, and the mathematician is more like an explorer finding a new continent. And this quote from Kronecker just says it all, doesn't it? For him, God made the counting numbers, and that's it. Everything else, especially crazy ideas like different sizes of infinity, was just dangerous fiction made up by men. And he would become Cantor's greatest and most bitter enemy. So how did Cantor actually prove these ideas that sounded so impossible? Well, he used a method that was so simple it's brilliant, but powerful enough to let him explore the wild landscape of infinity. It's a little something called one-to-one mapping. The idea is, forget about trying to count to infinity. You just can't. So instead, picture a giant ballroom. If every person from one group can find a dance partner from the other group, and there's no one left alone on the sidelines, you know you have the same number of people in both groups. You don't even have to count them. Cantor just took that super simple logic and applied it to sets of infinite numbers. And here's how it plays out with our original problem. You take the whole numbers, 1, 2, 3, 4, forever. Then you take the even numbers, 2, 4, 6, 8, forever. Can we pair them up perfectly? You bet we can. Pair 1 with 2, pair 2 with 4, pair 3 with 6. You see the pattern? For any whole number, let's call it n, you can always pair it with 2n. Since every single number can find a partner, and this goes on forever, the shocking conclusion is the sets are the same size. It feels wrong in your bones, but the logic is airtight. And this one simple tool led to his most revolutionary, world-changing discovery. He used it to show that even though you can count the whole numbers by pairing them up, you absolutely cannot do the same for all the numbers between, say, 0 and 1, the decimals that go on forever. There are just more of them. It's a bigger kind of infinity. He hadn't just defined infinity, he discovered there was an entire ladder of them, each one bigger than the last. A ladder of infinities. I mean, for a guy who thought he was a messenger from God, this was like getting a direct look into the divine blueprint. But for his colleagues, and for the church, this was heresy, pure and simple. And the attacks were vicious. His old rival, Kronecker, used all of his power and influence to sabotage Cantor's career, blocking his papers, denying him promotions, and publicly calling him a charlatan who was poisoning the youth. And the attacks came from everywhere. It wasn't just a personal feud. Famous philosophers like Wittgenstein just dismissed his entire life's work as utter nonsense. Cantor was basically an academic outcast. But maybe the attacks that hurt the most came from other people of faith. Theologians accused him of actual blasphemy.
They argued that by defining and categorizing infinity, he was trying to put a limit on God, to tame something that belonged to the Almighty alone. He was a human trying to measure the divine.
So, faced with these brutal accusations of heresy, Cantor, this devout believer, didn't abandon his math. And he didn't abandon his faith. Instead, he did something incredible. He built a whole theological system to show how his work didn't challenge God, but actually glorified him.
This is how he did it. It's actually brilliant. He said, look, there are three different kinds of infinity. First, there's the potential infinity. That's the simple idea of it keeps going. Then there's the transfinite. These were his mathematical infinities, that whole ladder of different sizes. He argued these were real, concrete ideas that humans could study because they existed within the mind of God. But, and this is the key, towering above all of that was the absolute. This was the true, ultimate, mind-bending infinity of God himself. And that infinity was completely off-limits to mathematics. And with his own words, Cantor drew a very clear line in the sand. His transfinite numbers were a paradise that God allowed mathematicians to explore. But the absolute, that was sacred ground. You could feel awe for it, but you could never, ever understand it with the human mind. See? His math wasn't an attack on God. It was a map of the foothills leading up to God's unknowable mountain. Now, Cantor's incredible struggle, this effort to use the most powerful tool he had, math, to get a handle on reality and the divine, it might seem like a strange, dusty story from the past, but it's not. It is an echo of a quest that is as old as we are, and a quest that is happening right now all around us. You know, throughout all of human history, we have had this impulse. We invent our most powerful, most advanced tools, whether they're intellectual or technological. And what's the first thing we do? We point them at the biggest, deepest questions there are. And you can see this amazing pattern right here. Go back to the 1600s, and you have Kepler using the new tool of geometry to try and read the mind of God, the celestial architect. Fast forward to Cantor in the 1880s, using his new set theory to map God's creation. And today? Look at the language around the race for artificial superintelligence. It's often talked about as our generation's attempt to be as gods, to create a mind from scratch. It's our modern Tower of Babel. So that's what I want to leave you with. Our tools, they've changed in ways we could have never imagined, from geometry to set theory to these massive neural networks. But the fundamental quest, the deep human need to point those tools at the mysteries of existence, has that really changed at all? What do you think?